Math 3, Unit 7, Section 5. Today we're talking about transformation of parabolas. So the first thing is that you want the parabola to be in vertex form, okay? We know that sometimes they're going to be solved for y and sometimes they're going to be solved for x. When you have a y equals equation, the graphs are curving up and down with the y-axis. Okay, where if they are x equals, they are curving right and left with the x-axis. In terms of translating, if you have adding c here at the end, it is going to go up. If you have a minus c, it's going to go down. If you have plus c in there, you would be setting that equal to 0, and that means that it'd be translating negative c on the x-axis, so that means that would be left, where here when you have x minus c, it would be translating right. When you have an x equals equation, it's a little different because there's the y value is in the parenthesis with the square term, and the x value is what is being added now at the end. And so this plus c here actually means that it's going to be translating right. Minus c would be left. And here you're setting y equals to 0. And so on the y-axis, it would be translating negative c, which means it would be going down. And this minus c would be going up. Okay, and we already derived all of our equations and everything. And so we always are going to let 4c equal the, we're not going to put denominator, it's the reciprocal of the leading coefficient. And that gives us our distance for the focus and the directrix. So here we have y equals 4c, 1 over 4c x squared. We use the c value to go up or down from the vertex. Here, when it's x equals, we're going to use the c value to either go right or left. Okay, and then the directrix goes in the opposite direction. We find the two focal chord endpoints by multiplying by 2c. And then we will graph the parabola using the focal chord endpoints and the vertex. So starting on this first example, when I look at these equations, I always want to see, okay, is my graph going to curve right or left? And we know that based on what it's equal to. So since this is saying x equals, it's going to curve with the x-axis, which means it's going to curve right or left. And then this being 1/8, it's positive, which means it's going to curve right. If this had been negative, it would be curving left. And so I just kind of like to put a little note to myself on here that I know the graph should be curving that direction to the right. So now we're going to find the vertex on your papers. I forgot to have vertex there, so you're going to want to add that. And the vertex for this parabola, notice here that this says y plus 1. So we set that equal to 0 and we get y equals negative 1. So for our vertex, in the y spot, we have negative 1. Which means that my x spot is negative 3. So the vertex is negative 3, negative 1, and we'll go ahead and make that point. Then we use our 4c equation. So for this problem, 4c equals the reciprocal of 1/8, which is 8. We then divide by 4 to both sides, and we get c equals 2. So from my vertex, since my graph's going right, I'm going to go 2 to make my focus to the right, and 2 to the left is my directrix. And we can go ahead and write the focus point, and that is negative 1, negative 1. And at my directrix, this line is x equals negative 5. To find the focal chord endpoints, we take our c value, which is 2, and we multiply that by 2, which is 4. So from the focus, we're going to go up 4, 1, 2, 3, 4, and down 4. And then we can curve our parabola, and we can see that it is curving to the right. Those focal chord endpoints are at negative 1 up 3 and negative 1, negative 5. Okay, we're going to go ahead and turn the page now. And we have another example here. You'll notice this one is not set up in our vertex form. So anytime you have something like this, we want to get the y by itself. Okay, and so the easiest thing to do first is divide by 2 to both sides. If you want to distribute the 2 and do it that way, you can. You'll end up with the same answer. But for me, it's easier, I think, to divide by 2. And so right now my equation, and I'm going to flip this around, is y plus 1 equals 1/2 x minus 3 squared. And then the last thing I would do here in order to get y by itself is subtract 1. And so now this is going to be in vertex form, y equals 1/2 x minus 3 squared minus 1. So once you have solved for x or y and you have it in the correct form, then we can graph it. Because this is y equals, we know it's going to be curving either up or down. And because my a value 1/2 here is positive, I know that the graph is going to end up curving up. So again, I'm just making a note to myself so that I can remember that, oh yes, it's going to be curving up and down. My vertex here, we set x equal to 0, and we end up getting x equals 3. So my vertex is at 3, and then that means that my y value is at -1. So we're going to go right 3, down 1, and make a point. From there, in order to find the focus in the directrix, we need to use our 4c equation. So 4c equals the reciprocal of 1/2, which is 2. We then divide by 4 to both sides, and we get c equals 1/2 or 0.5. So that means from my vertex, because my curve is going up, my focus is going to be 1/2 from my vertex. So I'm going to go up 1/2, and I'm going to label that with an F. And I'm going to go down 1/2, and that is my directrix. So as a point, my focus is at 3, -1/2, or -0.5. And my directrix is at y equals -1.5 or -1.5. Okay. Next, in order to get my focal chord endpoints, we take our c value and multiply it by 2. And so 1/2 times 2, or 2 over 1, ends up reducing, or you can multiply and get 2 over 2, and then that becomes 1. So for my focus here, at the focus, we're going to go 1 to the right and 1 to the left for my focal chord endpoints. And then this is going to curve going up. So my focal chord endpoints, one is at 4, -1/2, and the other is at 2, -1/2. Okay, moving on to the next problem. Again, this is not in vertex form, so we're going to have to change it to vertex form. So we want to get the x on this one by itself because the y is being squared. So we divide by 10 to both sides. These eliminate, and I get x equals 1/10 y minus 2 squared. Again, you have to add in your vertex line if it's not there on your papers. And to find our vertex, we know our vertex is an ordered pair. When I set this equal to 0, this is saying y minus 2. So y minus 2 equals 0 would give me y equals a positive 2. So in the y spot, we are going to put a positive 2. In the x spot, there is nothing being added here at the end, which means that the x part of the vertex is at 0. So we'll go ahead and plot that 0 up to. Also, I forgot, we want to talk about the direction. And so this is x equals, and it's positive here for the a value. So that means it's curving with the x-axis, which means it would be curving to the right. Now to find our focus and directrix, we use our 4c equation. So 4c equals, and the reciprocal of 1/10 is 10. We divide by 4 to both sides. And 10 divided by 4 is 2.5 or 2.5. So that means for my focus, I'm going to go right 2.5 from my vertex. So we go right 1, 2.5, and I'm going to label that with an F for my focus, and then left 1, 2.5, and draw my line for my directrix. The ordered pair for the focus is at 2.5 and then up 2, or you could put 2.5. The directrix is at x equals -2.5 or -2.5. The focal chord endpoints, for some reason that's written there twice on accident. So for the focal chord endpoints, we do that because we go 2c in each direction. And so my c value is 2.5, and so if I multiply that by 2, it equals 5. So from my focus, I'm going to go up and down 5. Okay, and then this is going to curve to the right. And if you're hearing anything weird right now, Bronson is in my room listening to a show. Okay, so we went 5 up and 5 down, and so my focal chord endpoints, this is at 2.5, and then it goes all the way up. This was 6 at 7, so 2.5, 7, and then the other one is 2.5, and that goes down to -3. So those are my focal chord endpoints. All right, turning to the next page. So now we're going to talk about the steps to writing the equation of a parabola using the definition of a parabola. So we've already done this a lot. We figured out the equation for all parabolas. We used our distance formula, and so that is exactly what we are going to do again here. The only difference is that my vertex for these equations won't always be at 0, 0, but it's the same process. So I'm going to talk through how to complete this, and we can reference our steps as we go through it. So when I'm writing the definition of my parabola, I'm going to use the focus and the directrix and a point, but the point I'm going to use is xy. So again, we're going to have PF equals PD. And my point is xy, and my focus is -2, 1. And again, my point is xy. And for my directrix, if we look up here, they gave the x value is 2, which means the y value will just be y. We are going to plug this into our definition in using our distance formula. So I have the square root of x minus -2 squared plus y minus 1 squared equals the square root of x minus 2 squared plus y minus y squared. So just to save a little bit of time, we know that y minus y ends up being 0. So that cancels out there. And we also know that 2 negatives end up making a positive. So now, in order to get rid of our roots, we are going to go ahead and square both sides. When I do that, I get x plus 2 squared plus y minus 1 squared equals x minus 2 squared. So prior to today, when we did this, we would have like a y squared here instead of a y minus 1, something in parentheses. And so the difference is, if you look back up here, it says expand the binomials containing a variable that occurs on both sides of the equation. So if you notice here, the x's are on both sides of the equation. So these are the ones that we are going to expand and multiply out because we can combine like terms. The y minus 1, we're not going to be able to combine with like terms, and so we're going to leave this as y minus 1 squared. So whichever where you can combine like terms, where you have the same letter on both sides, that's the one that you multiply out. and the one that's not the same, you leave it exactly as it is. So we are going to multiply out x plus 2 squared. We can use our shortcut. We know that x times x makes x squared. When I do my adding, 2 plus 2 makes a 4x, and then 2 times 2 makes plus 4. We're going to keep the y minus 1 squared, and then we're going to multiply this one out, and we know x times x is x squared. Negative 2 and negative 2 adds to be negative 4x, and negative 2 times negative 2 makes a positive 4. So looking at our like terms that we can eliminate our x squareds, and we can also eliminate our 4s. So when I rewrite the equation for what I have right now, I have 4x plus, sorry, there was a plus sign there, y minus 1 squared equals negative 4x. So we want to get all of our x's together. I'm going to subtract 4x to both sides. These eliminate. I end up now with y minus 1 squared equals negative 8x. And the last thing I do is divide by negative 8 to both sides. And so my equation is x equals negative 1/8 y minus 1 squared. Okay, so we're going to practice this again. Next example. Again, here we have our focus and our directrix. We are going to take the point to the focus equals the point to the directrix. My point will be xy. My focus is 1, 1. On the other side, my point stays xy. My directrix, since this says y equals 3, in the y spot I'm going to put a 3, and in the x spot I'm going to put an x. We are next going to use the distance formula for each side. So I have the square root of x minus 1 squared plus y minus 1 squared equals, on the other side, x minus x squared plus y minus 3 squared. To save us some time, we're going to simplify here. We know x minus x will end up making 0. We're going to go ahead and square both sides in order to eliminate my roots. I end up with x minus 1 squared plus y minus 1 squared equals y minus 3 squared. Whichever terms are like on both sides, we want to combine them together, and so I have to multiply them out. So in this case, I'm going to be multiplying out both of my y's because those match and I want to combine them together. The x term, I'm going to leave it alone. So I have x minus 1 squared plus, when I multiply this out, I get y squared minus 2y plus 1 equals, I multiply this out, I get y squared minus 6y plus 9. Like terms that I can eliminate on both sides, in this case, is only y squared. Nothing else is the same. But we want to combine our like terms together. Okay, so I want all the y's together on one side because we want to end up getting it to be y equals. So I'm going to add 2y to this side here, and that eliminates. And at the same time, I want to move this 9 to the other side because, again, I just want my y's by themselves. So I'm going to subtract 9 over here. So what I have right now is x minus 1 squared minus 8 equals negative 4y. And then the last step is to divide everything by negative 4. So I'm going to divide by negative 4 to both terms here. So that eliminates, and my equation is y equals negative 1/4 x minus 1 squared plus 2. Because negative 8 divided by negative 4 makes a positive 2. And that, is your answer. All right. If you have any questions, I can answer them later, and your homework is to do Unit 7, Worksheet 5.